my presentation, the title of my presentation was Metaphor Identification, a Feed-Forward Neural Network for Dependency Parsing. So as you would have guessed, it's based on metaphor identification, but it has a different spin on it. This is just an overview of what we'll be getting into. Now, before we actually get into the meat of what I have set out, what I have done, it is important to understand how metaphors relate to language. To put this project into context, so for the final time, language is essential for communication and expression, and language can either be figurative or literal. Metaphors lies within the realm of figurative language. So then what exactly is a metaphor? So it is an article used in human speech to view an item in terms of another, and it provides a reliable description of a situation by saying one thing is another. So over the years, there has been many pieces of research focused on metaphor identification, from hard-coded approaches to semi-supervised approaches to supervised approaches. But there were varying shortcomings found across each piece, which brings us into the problem. So as would have been seen in the other articles, identifying metaphors in text poses a major challenge in bridging the gap between natural communication between man and machine. But why? First of all, there is a difficulty in arriving at an objective criterion for pinpointing metaphors within a piece of text, which diminishes the variability of those systems. And secondly, there's a lack of effective techniques to aid machines in understanding text and differentiating language structures in text, which is known as dependency parsing. So then it can be argued that by creating a metaphor identification geared towards handling dependency parsing as effectively as possible is necessary to improve metaphor identification, which brought me to this hypothesis, which reads, an increase in the precision of identifying metaphors in text can be achieved by utilizing a feed-forward neural network in SyntaxNet for a stronger dependency parser. And the objectives were determine the advantages and disadvantages of metaphor identification implementations, investigate the possibility of using SyntaxNet for feed-forward neural network parser with the goal of arriving at a suitable level of precision, implement this new system, evaluate this new system against an existing approach, and determine whether we would have had some precision gain. So on to the methodology. So the entire study was based on, took some inspiration from a design science approach. So I would have gained new knowledge in a specific area, I would have revisited certain elements. And for the implementation, I would have combined the approach from an existing piece of work with the new parser approach. And I would have chosen the CCO algorithm and type 3 metaphors, which in the work of Newman was described as adjective noun pairs. To describe this algorithm, in summary, it works by grouping the co-locations of nouns that frequently occur with the adjective into concrete categories and determining whether the pair is a metaphor or not by the number of occurrences in each of those categories. But what was exactly new about this project? This is down to SyntaxNet. So how does SyntaxNet relate to other parsers? So firstly, it favors accuracy over speed. So in a test conducted, it was shown that SyntaxNet can perform at 94% at 600 words per second, compared to the next best parser, which was the Stanford NLP, which had 15,000 words at 92% accuracy. But the accuracy in SyntaxNet is accredited to the way the neural network is set up, as well as the accuracy of the models trained within the parser. And one of the features that we would have taken advantage of was beam search, which allowed the dependency parser to take the decision of a sentence at multiple different positions in the sentence. So we would have re-implemented the base CCO approach and then use the CCO along with my implementation of SyntaxNet for the evaluation and evaluated the two systems. And this is a flow chart of that process. So in essence, there is user input and our parser picks out the relation, and then it goes through the other steps of the CCO algorithm, which determines if it is an idiom, finds the co-located words, groups them into the categories, and then decides if it's a metaphor or a literal. So for the evaluation of the steps, I would have chosen 2 data sets, 2 corpus. So one specific to metaphors. So to prevent any biases in deciding whether a phrase or a sentence was a metaphor or not, I would have used this corpus, and the B and C for the literals. And I would have taken 100 samples from each, and I would have ran both systems on the same CPU with Windows 10 Pro. So on to the results. So the first result is the overall performance. So the accuracy, precision, and recall in the newer implementation was higher than that of the baseline. Recall in this case means the amount of true metaphors and true literals that were picked out by our system, which was 84 as compared to 78. And the precision had a 2.6 increase over the baseline. The same trend tended to continue in the performance of phrases where we could see although precision was closer this time, there was still a slight increase over the newly implemented system. And then again for structured sentences. So although the precision of both systems as compared to phrases were lower than there was still an increase in the newly implemented system, which let it outperform in the baseline again. So what do these fancy numbers all mean? So from a holistic perspective, the findings found within the current work are important as they suggest that metaphor identification can be improved by using more accurate dependency parsers. The results of the overall performance were as expected, boasting an increase in metaphors detected due to the parser's ability to better classify words and phrases in structured words and phrases and as well as for structured sentences, which would have been similar to work that we would have seen. So on to limitations. So the first limitation was that I could not control the mutual information rating due to the API. So a step in the CCO requires that you have a rating to determine the closeness of a word to another word to find the co-locates. And since I could not obtain that corpus, I had to use a different API which did not allow me to control this rating. And then there's the lack of dynamics due to the corpus and dictionaries used. So language is ever evolving. And over time, for this system to stay updated, you would continually have to update these corpus and dictionaries. So what does this mean for the average person? So voice-assisted technologies become more viable in industries such as healthcare. So for example, if a patient were to use natural language to describe illness to a machine, it would be able to understand and give more accurate prescriptions. Thus, we would have a more accurate healthcare system. Talking to machines could become natural in our everyday lives. And then there are benefits to similar work such as chatbots and Q&A bots. The absence of metaphor identification would result in the absence of metaphor processing, which would result in ineffective natural language processing. So for future work, an issue that still remains is that the CCO uses concrete abstractness of a target word, which can be improved by understanding the embodied sense of words through a field such as neuroscience, which was expressed by Newman in his work. And then there is metaphor interpretation. So metaphor identification alone does not offer a machine the ability to fully understand the meaning of metaphors. It should be coupled with some interpretation techniques to gain full value of any NLP-based task. And the approach can be extended to different languages as well. So in conclusion, we were able to determine that SyntaxNet is better for metaphor identification systems. We were able to utilize the feed-forward neural network for dependency parsing, and we were able to see some precision gain in the new implementation. And despite the limitation of mutual information with co-locations and lack of dynamics, the new system proved effective enough to replace the step of dependency parsing with the base concrete category overlap algorithm. That brings me to the end of my presentation. Any questions?